I'm going to give a presentation on Meroplankton dynamics, and mostly this is in connection with the life cycle of various Meroplankton in transitioning between benthic and pelagic habitats. Most of the zooplankton studies mostly focus on copepods because they are the major component of the zooplankton. But Meroplankton are usually neglected. So I thought from our monitoring data that I should have a look at some of the Meroplankton dynamics from our data. Now, what is Meroplankton? Meroplankton is a component of zooplankton, but they are not, they only spend a portion of their life cycle within the plankton, as opposed to holoplankton, which are born as members of the plankton and they will die as members of the plankton. So Meroplankton are temporary plankton, and usually their residency time in the pelagic zone can be from few days to weeks. But generally, they are only there for a short while as part of their life cycle. And most of these organisms are usually benthic organisms. For example, crabs in their larval stages. And it's actually their larval stages that we mostly find in plankton samples. But as soon as they go through metamorphosis, they become adults and they move to the benthic, habitat. So typical temporary plankton that we find are, like, for instance, the phylosoma of the various lobsters. We have got crab larvae, echinoderm larvae, etc. Polychaete larvae are also some of the temporary plankton that we find in our samples or in typical plankton samples, as well as gastropod larvae, as well as sea anemones. So these are typical temporary, so-called temporary plankton. Often benthic organisms, they have a very complicated life cycle. This is a schematic of looking at the life cycle of a barnacle. And there is that phase whereby the nuclei are present in the pelagic environment. And as it transitions from one stage to the adult stage, the eventual adult stage moves to the benthic and become benthic. They move to the benthic environment. But that is the connectivity that one has between the pelagic environment and the benthic phase. The other example is also, for instance, rock lobsters, which have a very intricate and complicated life cycle, whereby the adults, you find when they spawn or when they mate, then usually they are in deeper waters, but the larval stages usually drift for quite a number of months in the pelagic environment before they move towards the benthic environment. Now, why should we be interested in Meroplankton? Because they can be used as indicators to show shifts in community dynamics. And also, they can be very important predictor of emergent benthic populations or communities. And at times, Meroplankton can form a very significant portion of the total zooplankton biomes. This is an example of a study from monitoring station in the UK, and clearly it shows, for instance, for a lot of Meroplankton, sometimes of the year, for instance, here in March and April, it forms a very more than almost 50% or close to 50% of the total zooplankton abundance. But of course, during some parts of the year, then they simply disappear, or there's only a very small portion of Meroplankton. Now, what I did was now to look at, because we've got almost 20 years of monitoring data, and the Meroplankton, as I said, has been very much neglected. So I started exploring this monitoring data and extract some of the meroplankton that we find in our samples or in the data that we have. Now, I focus mostly on the broad taxonomic groups, mainly bivalves, Steripedia, Decapoda, Echinoderms, and Polychaeta. This is the reason why the focus on the broader taxonomic groups is because larval stages are very difficult to identify, and also various people have been identifying the samples over the years, so there's a lot of variation sometimes in terms of the expertise. But at least the broader taxonomic groups gives us an indication of what species are most likely to be in that group. And this is really a preliminary analysis, but some of the questions that one can get from such an analysis is things like what the contribution of meroplankton to total zooplankton abundance is, which groups are important. One can also look at seasonal, interannual, and decadal variability. And also, although I've not done this at this stage, for instance, to look at which environmental variables may explain meroplankton dynamics, and obviously in the broader scheme of things, how might future climatic changes affect meroplankton dynamics? So these are some of the questions that one can get from analyzing this data. Now, the context in which one has to look at this is in terms of phenology and climate change, because climate change in many parts of the world, it has been shown it affects the seasonality and variability of the organisms. And phenological events are events that are recurring at a specific time, but due to global change, it's possible that, or it has been shown in many planktonic communities, for instance, there's shift in their seasonality. So looking at phenology of meroplankton, one, it can act as an indicator of change, global change. As I said, this is just a preliminary analysis. Still more needs to be done, but at least it can give us already some idea as to the trends of meroplankton. Here, I'll try to develop the seasonality of meroplankton over the 18-year period, and May and October seems to be the months where we have got the highest peak abundances. Whereas for the other times of the year, like January, February, it seems to be less important. If one looks at this in terms of the groups, then in May, for instance, the peak abundances are dominated by echinoderms and polychaetes. The same with October, where echinoderms or echinoderms are the most dominant ones. Other noteworthy trend for observations is like the Steripedia, which are mostly barnacles, are most of the time absent, but only becomes visible around November. But decapods, the same. Decapods are not important throughout the year, but around November, there is decapod seems to be emerging. Then, in terms of interannual variability, the years 2003, 2004, meroplankton abundance was quite significant compared to the other years. Also, 2014, the abundance was also quite high, whereas the years 2006, 2009, the abundances were quite low. If we look at that in terms of the 5 groups, then again in 2003, 2004, echinoderms were a major contributor. Also in 2014, echinoderms were predominantly highly abundant. If we look at the cross-shelf variability, then of course inshore one would expect to find more meroplankton, but also towards the offshore, as one moves towards the offshore, then the abundance becomes less. These are stations on the horizontal axis. These are the stations from inshore towards the offshore. Again, if we look at the abundance in terms of the groups, then at the inshore stations, the bivalves and the echinoderms were predominant, whereas towards the offshore, polychaetes were mostly the dominant ones. In summary, meroplankton peak in May and October, and it's mostly dominated by echinoderms and polychaetes. Bivalves, Seripedia, and decapods, they are low throughout the year, with decapods with a small peak only in around November. There is high interannual variability. Seasonality seems not to be well defined, but it was somehow relatively higher in winter, which is during the upwelling period. In terms of bivalves and echinoderms, they dominated inshore, but this is only a preliminary analysis, and also considering the sampling, the mesh size that we're using for our monitoring program, which is 200 mesh size. I think with a smaller mesh size, the abundance could be much more higher. So so the current data may seem to it may suggest that it's not so much abundant, but if one considers to use a smaller mesh size, then I think it will be much more higher. And with that, I come to the end of my presentation.